We end this part 2 in Unit 3, in something that's, I think, kind of straightforward. You will have a question on your test probably about this, but do you buy this, that cations are losing electrons, and so they will always be smaller than their original neutral atom? And anions actually are gaining electrons, okay, and they will always be larger than their neutral atom. To me, I'm like, oh, I totally see that. This is kind of a review slide we talked about with regard to neutral atoms. A neutral atom is going to be smaller, or forget I said that, but we said a neutral atom or an ion. We have these attractive forces, the electrons going in towards the nucleus, and then we have these repulsive forces between the electrons. And we said that if attractive forces increase, it gets smaller. Repulsive forces increase, it gets larger. Of course, the thing that creates the volume of an atom or an ion is what its electrons are doing in the cloud outside the nucleus. So, like I said, as repulsive forces increase, it gets larger. As attractive forces increase, it gets smaller. So here we have a kind of a comparison of a couple of metals that are kicking off electrons. Sodium will kick off one electron and become a +1 charge. What does PM stand for? That's picometers. So 186 picometers to 99 picometers is the decrease in size. And to me, I mean, it lost one electron. Okay, magnesium lost what? 2 electrons and became this size. Okay, so I just think that is kind of straightforward. Here we have the table salt, sodium chloride. Okay, and we said that sodium, the metal, will kick off 1 electron. Chlorine, the non-metal, will take 1 electron in, and you can kind of see the chlorine getting larger and the sodium getting smaller. Now, one of the things you've heard me kind of stumble on a little bit is for the anions, we actually, for monoatomic anions, we take the root of the name instead of chlorine, we lop off INE and change it with with IDE. Okay, so anyway, the chloride ion. All right, but that wasn't my point here. So here, of course, we see the chloride ion getting larger compared to the chlorine neutral atom. And this is just kind of a quick look at all of the, of course, or several, not all of them, I guess, right? So here we see the JAG. The JAG separates what? The metals from the non-metals. And you can see the green are the anions, negatively charged anions, getting larger than their parent. And the blue here are the positively charged cations. They're smaller because they've lost an electron or 2.